Imagine you walk into a busy restaurant, hungry and a little short on time. You tell the waiter what you want. They head to the kitchen, and 10 minutes later, you have exactly the dish you asked for. No need to open the stove yourself. That simple back and forth is the secret handshake of the internet, and it's called an API. Picture this. It's Friday night. You and a friend sit down, menus in hand, decisions to be made. The waiter arrives, friendly and efficient. You say, "I'll have the marinated salmon, no nuts, extra lemon." The waiter repeats it back to be sure, walks into the noisy kitchen, tells the chef exactly what you said, waits while the chef prepares the plate, and then brings it back to the table. You taste it, and if something's off, the waiter takes it back, gets it fixed, and returns. Everything works because the waiter speaks both your language and the kitchen's language, and because there are clear rules about how orders are communicated. That's the whole idea behind APIs. In our everyday devices and apps, the waiter is the API, a messenger that carries requests from one part of the system to another and brings back the answers. The customer is your app or your browser. The kitchen is another server, a database or a service somewhere on the internet that actually does the work. The menu is a list of things that service can do for you, and the plate that arrives is the data you wanted. Let me walk you through the pieces in plain language. An API, short for Application Programming Interface, is simply a set of rules that lets one program talk to another. Think of it as the restaurant's ordering protocol, where you sit, how you indicate a special request, whether you write it down on a pad or use a touchscreen. The rules make sure everyone understands each other. A request is the order you give the waiter, what you want, how you want it, any special notes. A response is the plate the waiter brings back, the result of the kitchen's work. If the kitchen can't make the dish, the waiter explains why, maybe suggests alternatives. That's like an error message from an API. There are a few more bits that come up again and again. Authentication is how the waiter checks you're a paying customer. Maybe they look at your reservation or your ID. In the API world, it's how a service proves you have permission to ask for something. Rate limits are the restaurant's rules about how many orders one table can place at a time. They prevent chaos when everyone tries to order 10 items at once. Versioning is the seasonal menu. If the kitchen changes a recipe, the waiter needs to know whether you want the classic dish or the new one. Caching is like the kitchen keeping a few popular dishes prepped and ready so they can be served faster during a rush. And error handling is the waiter smoothing things over when the soup is too salty. How the system explains problems and helps fix them. To make this concrete, let's follow two everyday scenes where APIs play the waiter role you never see. Scene 1. You open a weather app to check tomorrow's forecast. The app, that's you at the table, asks the weather service, the kitchen, what will the temperature be in my neighborhood at 9 a.m.? The app sends a request with your location and the time. The weather service looks at its instruments and forecasts, packages the answer into a neat format, and sends it back. The app shows you 58 degrees Fahrenheit, partly cloudy. If the weather service is busy or down, the app might show an old forecast it cached earlier or an error message saying it can't fetch new data. All of that is the API waitstaff quietly doing its job. Scene 2. You buy a pair of shoes online. At checkout, the store asks a payment service to charge your card. That request includes the amount, currency, and a token that proves you're allowed to use that card. A brief ID check the waiter performs. The payment service replies with payment approved or declined. If approved, the kitchen, the shop's order system, prepares the shipping label and sends you tracking info. If declined, the waiter tells you and maybe suggests calling your bank. The store doesn't need to know how the bank processes payments. It just needs the trustworthy message from the payment API that the charge happened. A few more simple comparisons will help lock this in. Some APIs are like a fluent waiter who can take complicated, detailed orders. special cooking temperatures, allergy notes, and substitutions. These are flexible APIs that accept a lot of information and return complex replies. Others are like a quick sandwich order window. You say ham and cheese, and you get back a sandwich, fast and to the point. Some services insist on formal language. Some accept casual phrasing. Those differences are why programmers talk about different styles of APIs, but you don't need to worry about the names to understand the role. They're all waiters, just with different personalities. And there are reasons why this setup is so useful. By having a waiter handle the conversation, the customer and the kitchen don't need to know about each other's tools. You don't have to carry a stove to your table, and the kitchen doesn't have to memorize every diner's taste. That separation lets restaurants scale. Add more tables, more waiters, or another kitchen location, and things still work. The same goes for online services. If an app needs weather, payment processing, mapping, or translations, it calls the respective API without rebuilding all that functionality from scratch. Sometimes there are hiccups. Maybe the waiter misheard no nuts and the chef added peanuts. That's a bug. Maybe the kitchen runs out of salmon. That's an unavailable resource. APIs handle this with polite error messages, fallbacks like offering chicken instead, and retries. Better systems even keep a backup kitchen or pre-made dishes so hungry customers aren't left waiting. Those are technical strategies called redundancy and caching. But in restaurant terms, they're just smart ways to make sure everyone gets served. Before we wrap up, here's a quick recap tied back to our waiter. You, the app user, are the diner. Your app is the customer speaking to the waiter. The API is that waiter, repeating your order, translating it into kitchen speak, bringing back the dish, and explaining what happened if something goes wrong. Services like weather data, payments, maps, and social feeds are the kitchens that actually prepare the food. Authentication is the waiter's ID check. Rate limits are the table's ordering rules. Caching is prepped food on the shelf. And versioning is the seasonal menu. So the next time your phone loads a new message, your smart speaker answers a question, or an online checkout completes in a blink, remember, there was a small, reliable waiter behind the scenes, quietly running between your request and the people who can fulfill it. APIs are the unsung hosts of the internet, making complex systems feel simple, one order at a time. Thanks for sticking with the story. And if you liked hearing tech explained like dinner, I've got more recipes coming. If you enjoyed this, like the video and subscribe for more stories that make tech feel human. See you next time, friend.